Hello everyone. In the Postman API testing series, we will discuss basic API terminology today. Also, we will learn how to install the Postman application on our system and prepare it for using the Postman tool. If you have not watched my first video in this playlist, please do so and continue with session 2. If you like the video, please subscribe to the channel to support me. Watch the video till the end. Let's start today's session. Before starting today's session, let's take a look at today's topic. First, we will recap what we covered in the first session. After that, we will delve into the differences between SOAP and RESTful web services. How many types of HTTP requests are there? Requests from the client to the server involve how many types? We will discuss GET, PUT, POST, and delete in this context. Following that, we will explore what URI, URL, and URN are, highlighting the distinctions among them. Subsequently, we'll examine the components of a URL. After this theoretical discussion, we will proceed to prepare our system to work with the Postman tool. This involves downloading the Postman tool and installing it on our system. With these preparations, we are ready to commence today's session. In the last video, we discussed how web applications work, covering topics such as client-server architecture, APIs, the importance of API testing, and the layers involved. If you haven't watched the previous video, I recommend doing so to better understand upcoming topics. When we open a web page on our laptop, the laptop acts as the client, and the actual software is hosted on a server. The client, laptop, mobile, or desktop sends a request to the server over the internet. This request doesn't directly reach the server. Instead, it goes through an API on the server side. In short, the presentation layer, PL, is where we interact with the web page and perform web testing. Components like drop-downs, buttons, and scrolling are tested using tools like Selenium. The API layer, also known as the business layer, contains the business logic, and API testing is conducted here. Requests pass through the API layer to reach the server, also known as the backend or database layer. Database testing is performed at this layer. The communication between the client and server, involving request and response, includes the business layer. The three-tier architecture consists of the presentation layer, API layer, and database layer. These layers are responsible for client system, API server, and databases, respectively. Developing the API layer requires programming knowledge, while the presentation layer is developed using scripting languages like CSS and HTML. Separate teams handle the development of these layers. APIs are developed using languages like Java, Python, or C#. The database layer uses databases such as MySQL, MongoDB, Cassandra, etc. Separate teams are responsible for maintaining databases. API testing is conducted directly in the API layer, as there's no need for the presentation layer in this process. Requests are sent directly to the API layer, and responses are obtained in API testing. This is our presentation layer, where our web page resides on the client side. Moving on, this is our business logic, referred to as the API layer, and this is our database layer. As mentioned earlier, in a typical scenario, the request goes from the client to the server through the API layer, and the response is retrieved from the database layer through the API layer back to the client system. During API testing, there is no need for the presentation layer. Whatever request we have, it is directly sent to the API layer using any API testing tool, and the response is obtained in the API tool. Do you understand? There are two types of APIs, SOAP and RESTful services. Both fall under the category of web services. As mentioned before, all web services are APIs, but not all APIs are web services. let me quickly reiterate the difference between web services and APIs. APIs are developed by developers and sent to the testing environment for testing. In this phase, internet connectivity is not required. However, when the API is placed in the production environment, internet access becomes necessary to interact with the APIs, making them web services. I hope this clarifies the distinction between APIs and web services. Additionally, it's worth noting that SOAP is an older web service, while REST is widely popular nowadays. Now let me explain the differences between SOAP and REST. SOAP, which stands for Simple Object Protocol, and REST, short for Representational State Transfer, are two different approaches to building web services. When we talk about web services following SOAP principles, we call them SOAP web services. Conversely, those adhering to the REST architectural style are referred to as RESTful web services. Now, when it comes to performance, SOAP message requests tend to be processed slower compared to REST. The reason behind this is that SOAP involves more overhead due to its XML-based messaging. On the other hand, REST message requests are processed faster, primarily because REST follows a stateless communication model. Another notable difference lies in the data format. SOAP supports only the XML data format, while REST is more versatile, supporting various data formats like plain text, XML, HTML, JSON, and more. In terms of implementation, SOAP is known to be more complex and not as easy to implement, making it less preferred in certain scenarios. In contrast, REST is simpler to implement, which has contributed to its widespread adoption, especially in web and mobile applications. Considering bandwidth and resource usage, SOAP requires more of both due to its XML nature. In contrast, REST requires less bandwidth and resources, making it more efficient, especially in situations where resources are constrained. So, the choice between SOAP and REST ultimately depends on the specific needs and constraints of the system you're working with. Now let's delve into some important terms before moving on to API testing. As I mentioned earlier, the client sends a request to the API, which processes the request in the database layer. The database layer then provides a response back to the API, and the API sends this response back to the client. This is where our request is, and here is our response. This represents the server side. The request is an HTTP request. How many types of requests are there, and what do we receive in response? In response, we get not only the status, but also data, commonly referred to as payload. Along with the request, additional information is sent, known as payload. Now, let's explore the various types of HTTP requests, and we'll discuss that in the next slide. To test an API, what do we need to do? We have to send a request, right? The API processes that request, sends it to the database layer, and produces a response, which is then sent back to the client system through the API layer. In this process, we'll learn how many types of requests we can send and what types of responses we can expect. When testing any feature of an application, it's crucial to understand the associated requests and the expected responses. This knowledge is essential for effective API testing. A feature, in this context, refers to functionality, and we have different types of requests to interact with APIs. Firstly, there's the GET request. Let's see what a GET request does. When we want to receive data from the database, we use a GET request. The data in this context is also referred to as a resource. This type of request is considered one of the safest because it doesn't change anything in the database. The second one is a POST request. What does a POST request do? It creates information in the database or, in simpler terms, it creates a resource in the database. The third one is a PUT request. It updates data in the database, meaning it modifies existing data in the database. The terms data and resource are repeatedly used in API testing. The fourth one is a delete request. It removes data from the database. These 4 HTTP requests are crucial for API testing. Now, let's talk about the response. What do we get in response? We receive a status, typically 200, which means everything is okay. Additionally, we get a payload. It's important to know what response to expect for each request. We need to remember terms like payload, resources, and data. Now let's proceed with the exploration of API testing. On the Internet, we have a plethora of resources and a vast amount of information. The challenge lies in identifying and accessing these resources. For this purpose, we use Uniform Resource Identifiers, URIs. Most of us are familiar with this term, right? To identify any information, we use a URI, which stands for Uniform Resource Identifier. Let's take Google's website as an example. What is the URI of the Google website? It's google.com. Now, how do we locate this URI? How do we reach it? For this, we have a protocol, and the protocol used to reach the Google website is HTTPS. The combination of URI and protocol is known as a URL. There are other protocols like HTTP, SFTP, and FTP. Now, what's the difference between HTTP and HTTPS? The extra S in HTTPS stands for secured. For example, if we use a username and password, our credentials are safe because they are encrypted. In contrast, HTTP lacks this security feature. When we want to transfer files, we use the FTP protocol. Additionally, there's a term called URN, which stands for Uniform Resource Name, and URL stands for Uniform Resource Locator. Let me give you an example of a URN. Imagine we have a friend named A, and A has an address shown on the screen. In this analogy, A is the resource, and the address is called the URL. However, since there may be multiple people with the name A, we prefer to use URLs instead of URNs. To summarize, to identify resources on the Internet, we use terms like URI, URL, and URN. It's important to note that all URLs are URIs, but not all URIs are URLs. In the next slide, we will discuss the components of a URL. I hope this clarifies what URI, URL, URN, HTTP, and HTTPs mean. We have 2 crucial components, protocol and domain. In the protocol, we can have various options like HTTP, HTTPS, SFTP, or FTP. For example, instead of HTTPS, there could be HTTP or another protocol. In the domain, we specify the address, such as www.google.com. Once we reach the domain, if our data is inside a folder, we mention that folder's name after the domain. This is known as the path. For instance, if the requested page is inside a product folder and named registered.php. The path is product. So, the 3 main components are protocol, domain, and path. Additionally, there is another essential component called the query, which always comes after a question mark. For instance, when we search for something on Google, the search query comes after the question mark, like search Bing. So far, we've covered 4 components: protocol, domain, path, and query. There's also the consideration of the port, such as 8080, 8000, or 80. Now that we understand these components, let's clarify their roles. In the diagram, we see scheme, which is the protocol, host, which is the domain, and path, leading to the requested resource. The complete term for this is URL, and sometimes we refer to it as URI. We've already discussed URN in a previous video. Lastly, let's briefly discuss installing Postman. To do this, go to the official Postman site, download the compatible version, and install it on your system. Postman can be installed either as an executable file or used as a web version. To register, a Gmail ID is required. Make sure you have an email ID, download Postman from the Internet, and install it on your system. To download Postman, we opened the Chrome browser and visited the official Postman website. There, we found a link to download Postman for Windows 64-bit. Clicking on this link initiated the download process, and we observed the download progress. Once the download was complete, I saved the executable file on the desktop. To proceed with the installation, we need a Gmail account. Before starting the installation, ensure that you have a Gmail account. To install Postman, double-click on the exe file. This action brings up the installation screen. The first step is to create a free account. Click on the Create Free Account option as shown on the screen. On the next screen, provide details such as email ID, username and password. After filling in all the required information, click the Create Free Account button. Alternatively, you can choose to create an account directly with Gmail. Remember your username and password, as they will be needed for future logins to Postman. Once the account is successfully created, you'll see the Postman page. After completing these procedures, a Postman shortcut will appear on the desktop. Double-clicking on it opens Postman. Now, let's create a workspace. A workspace helps organize and collaborate on APIs. Click on the Create Workspace button. Provide a name for the workspace. Summary is optional, and select the visibility option. You can choose between personal, private, public, or team. For now, I'll choose personal. Click Create Workspace, and your workspace is ready. Workspaces can be managed by creating new ones, viewing existing ones, or deleting them. To do this, click on the Workspaces option. You can also change the visibility in the workspace settings. Additionally, you have the option to rename workspaces. After installing Postman, the first step is to create a workspace. You can also rename workspaces as needed. Now our system is ready with the Postman tool. Let's wrap up this session, and I'll see you in the next one.